In this video, I want to give you a quick tour of RStudio, which is the main thing that you will be looking at while we continue in this course. When you first open up the program, you will see a 3-pane layout, but usually when you work with RStudio, it looks more like this. So you have a 4-pane layout. Starting from the bottom left, you can see the console. This is R in its pure form, and as I showed you in the installation video, you can simply do a couple of calculations here to see that it is actually working. You can use the message command to print a message to the screen, and you can basically do all the things you want to do in R. However, this quickly gets cumbersome if you just copy and paste commands in here. You don't really know what you're doing, and in the introduction I said that you usually want to work with scripts or to write down your commands basically, so afterwards you see what you've actually done. So whenever you enter a command, you enter it on the top left here in the scripts pane. And here what we could do is add another calculation, and then you should hit Control and Enter to run it down here. So you don't have to copy it from the script to the console. You can just leave it in the script, and you can either press the Run button, or as you can see here, it shows you pressing Control and Enter on your keyboard will do the same thing. Moving on to the right, you see the environment tab here in the pane on the right. And this is basically all the things that are saved in your environment. So in R, you work with objects usually. We can quickly create an object by simply assigning a value to a new vector we call x. Let's say this has the value 8. And when you run this command now, you can see here on the right that x has the value 8. And when you hover over it, you can also see that it is a numeric value and the size of the object in memory. So now that you have this object, you can do calculations with this. And R just treats this as the number that lies behind it. Moving on, you also have the history tab here. I recommend you don't look at this too much. You should usually always go the route to write down your command here and run it. You see the result down here in the console, but sometimes you might have entered a command down here and you want to go through the history, and you can actually copy from the history directly to your source pane by hitting this button right here. Now it's over here and you can run it again. Connections and tutorials, we won't use those two, so just ignore them for now. The files pane here is basically a simple file manager. It is also not really important right now. Once we get into projects, it will get more important, but right now don't really pay too much attention to it. Plots is currently empty because we don't have any plots right now. We could do a quick histogram by using a built-in dataset, the islands dataset, for example. And once I run this, you can see the plot right here. You can right-click and save it as an image if you want, but I will show you better ways of getting your plots out of RStudio later on. Then we have the packages pane here, the packages tab, and this is useful because we will use several different packages during the course, and you can install them here rather than in the console. The advantage here is that it has auto-completion. So for example, if I wanted to install the tidyverse, which is the main package that we will use, or rather it is a collection of different packages, it will show you here the full name of the package, and you can hit install, and it will simply put the command to the right here, to the left here. I'm not going to do this right now because it takes quite a while. Rather, we move on to the help section, and I'm just using some command, and as you can see, RStudio has a nice autocomplete built in. We're just going to check the help file for the install packages command, and this is not very interesting in itself, but the help files are always structured in the same way, and I think it makes sense to explain to you quickly how you can read those help files and how they are structured. So they always start with a title, which is usually a very short description of what the function is doing. In this case, it says that it's installing packages from repositories. So basically the CRAN repository that hosts all of the different packages in the R universe. Then second, you see the description here. It is usually a bit longer than the title, and it explains in more detail what exactly the function is doing. Then you have this usage segment here, and it basically lays out all of the different arguments that a function has. So the function in this case is this part, install packages, then you open the brackets, and then you have the different arguments to them. So what we just saw here, going back to the install packages command, I entered tidyverse. It is the first argument in here. So what R automatically does is it interprets it the same as I would write if I spell out the name of the argument here. So this is the same as leaving it out, and then it runs the function with all of the default settings. So you can see the default setting by checking what comes after the argument. And when you see the default for dependencies here, it says NA. If we scroll down and look at the explanation for the arguments, we can check again what this means. So dependencies, NA means that the function will install dependencies, imports, and linking to dependencies of the package. So of the package. So if a package, for example, tidyverse, it has the dependency dplyr. So if you install the tidyverse, it will automatically also install the package dplyr. Usually you can leave all of these out. A function only normally requires that you provide one value for one argument. In this case, it's enough to supply the packages argument here, and it will just use all of the other arguments here. If you check here, there's one special argument, which are called the ellipses, or often the dots. This basically means that you can pass on other arguments to underlying functions. So if you check here, the ... will be passed to download file and available packages. If I check that here, then download file uses the method argument. So if I wanted to use a different method, I could just pass in the argument here what kind of methods are available. wget, for example. So this would work perfectly well, I think, because I have wget install, and it just uses a different downloading method. As I said, through the three dots, an argument gets passed down. So if you don't find in a function the argument that you're looking for, you can check the three dots. Usually the developers of a function think carefully about what default values to apply here. So for install packages, I pretty much never used any of those other arguments because the defaults make sense and they work fine in 99% of cases. If you then scroll further down, the next section is the details section. This is usually not very interesting. The only times I check the details section is when a function isn't working as expected, and I want to see if the developers of a function left some clue why it doesn't work in some cases. Sometimes you have the value section. This gets used less and less, I have to say. And here it says that the value that is returned, so value always means what the function returns to you, is invisible and null. So basically, it doesn't return any value. Yeah, there are more details here, so these are all parts of the details. Where it gets interesting again is the example section. This is how I usually learn a new function, by just copying the example. I know that this is working, so the examples of a function always work that you find in this help file here, and then I can adapt this example to my own needs. So I would run this once and then say I don't want this configuration arc here, so I delete it, but I already know that this probably works fine. Don't worry when you see this, the not run comment here. It just means that the examples are not included in the daily tests that are run on every package, on every function on the CRAN servers. And then the last thing is the viewer. It works very similarly to the plots pane here. And you will see something down here basically when R determines that you want to see it right now. This is the same as the plots pane. So if I hit enter here again in our histogram, it will automatically change to this view. The same is true if I use the question mark and the name of a function. Let's try hist for histogram. Then it will automatically open the help tab over here. Now, finally, I wanted to show you two more things that only come up much, much later in the book after you've done some initial data science, but I think it makes sense to show them to you now because you will immediately develop a better workflow. So the first is RStudio projects. You can create a project by going up here and selecting new project. No, you don't want to save the current workspace. Then you can find this new directory. You want a new project, and then you can simply add the directory name here. So let's call this our data science. You can call this whatever you like, but yeah, this is what I'm using, and I'm saving this in my home directory. So now you're in this project, and the advantage is that whenever you come back to this project, all the scripts that you had open and everything else is exactly how you left it. I would usually not save the workspace. It makes sense to always start with a clean slate. The second thing I want to show you are markdown files. And I'm creating a new one here. I need to install the package first, which is fine. So I'm calling my new R markdown file just one intro or something like this. I'm the author of this file, so I can enter my name here, and it's okay to go with the HTML file first. This is open now, but it's not saved yet. I want to save it in my Studio project directory, and I'm giving this the same name as the title, and I'm adding the file extension .rmd to indicate that it's an R markdown file. Okay, once this is saved, we can have a look at it. The part up here is called and it basically lays out some ground information about this script. Then you start with an R chunk. R chunks always have this indication here, those symbols that show you, okay, this is where it starts. Then we have a part of Markdown language, which is basically a very simple programming language used for writing. The hashtag here means that this is a second order headline. If I removed one, then we have a first order headline, or if I add 2, then this is a third order headline. We have another small code chunk here, another headline. If you wanted to use a new R chunk, you could press Control, Alt, and I. So it automatically adds this here, and we can simply create a new object, as I showed you already, and we can print this object by simply calling on it. Now, the reason I show you this is because I think RStudio and R are incredibly powerful when you use them in combination with R Markdown. Because what you can do is you can knit this script directly, which means that R will run all the code chunks and create a document from this. So if I do this now, it evaluates the code and it produces this nice file here, which is an R HTML file, and you can open it in your browser to look at it again. You can see it used a summary command to show you a bit of stuff about the cars dataset, which is built into R. It created this plot, put it directly in your report, and it also did the extra stuff that I added down at the bottom. So now HTML files are a little bit strange. They're really useful, but you probably never worked with them directly. You could also compile this into a PDF or into a Word file. Let's do Word. It runs again, and then it opens the file in a Word document, which you should be familiar with. And when you look here, you see that, as I said before, this part has been formatted as a level 2 heading. You can also see that this word here has been boldened, so it's in bold font. If we look at the word over here, you can see that it is surrounded by 2 stars. That's part of the Markdown syntax. If I add 3 stars, then it is both bold and italic. You can find more information about R Markdown on this website here, but for now I think that is really all we need. I encourage you to use these R Markdown files from early on because it makes it much easier to keep track of your own progress while you work through this material. Then finally, 2 more things about RStudio. The first is that I used a couple of keyboard shortcuts already. You can find a nice little help file up here. If you go to keyboard shortcuts help, it will display a lot of the great keyboard shortcuts that the developers of RStudio have created. So you can find Control, Alt, and I up here, insert chunk. So this is really for just for our Markdown files. You have a couple of the usual commands like Control and S to save, and so on. So familiarize yourself with a few of these commands, with a few of these shortcuts here. If you find yourself often using one of the buttons or looking up something, then there's usually a keyboard shortcut here. The second thing is that you can customize RStudio to your liking. You can go to global options here and change, for example, the appearance if you don't like the light mode here. You can check out a different editor theme. For example, we could use this tomorrow night here, and when you hit apply, it will restart RStudio in this nice dark mode here. Another thing that you can change is the pane layout. So for whatever reason, I usually prefer to have my environment on the left and to have the console on the right. So this is how I usually work with my environment here and the help files and so on down here on the left. And I think that's it about RStudio. In the next video, we will finally start writing some R code and doing some interesting visualizations.